Hello student, welcome to Study by Technology, and in our today's session we are going to solve a couple of questions. Okay, now the first example that we are going to solve here is, let's say we have two triangles, two acute triangles actually, this one and the second one is this one. Alright, now this angle is, let's say, A, B, C, this one, and in this case this is P, Q, R. Here we have this one. Alright, and it is given to me that sine B equals to sine Q. Alright, and we have to prove that angle B equals to angle Q. Right, now let me show you how we can write this in your examination and how we can proceed to prove this. Okay, now the first thing is, what you have to write is, given okay, what is given to you is sine B equals to sine Q. This is given in your question. Now the next one is to prove. This is the next heading. Alright. What you have to prove is, you have to prove that angle B equals to angle Q. Right. Now we have something to prove. Okay. So for this, let's say, first of all, as it is given to you that sine B equals to sine Q. Now what is sine B? That is perpendicular upon hypotenuse. That is AC upon AB. Right? Similarly, what is sine Q? This is equal to PR upon PQ. Alright. Now as the condition is given to you that sine B equals to sine Q, in that case AC upon AB, this will be equal to PR upon PQ. Alright. Now if we make it a cross multiplication, this will be like AC upon PR. So this will be equal to AB upon PQ, right? AB upon PQ. And let's say consider it like this is equal to K. Just we can consider it. Alright. Now if we talk about the base BC, according to the Pythagoras theorem, this will be under root of AB square minus AC square. This is the first equation. Consider it like that. And in the same way, this QR This can be written as PQ square minus PR square. Consider it as equation number second. Right? Now put it BC upon QR. This will be equal to under root AB square minus AC square upon under root PQ square minus PR square. Right? Now what we can do is, right, AB, this can be written as K times of PQ. So we can write it like K square PQ square minus this AC can be written as K times of PR as well. Right? So this will be K square PR square whole upon under root PQ square minus PR square. Now we can take K square as common, so it can be taken out as K from this square root, and here we can have PQ square minus PR square upon under root PQ square minus PR square. Fine. Now you can cancel both of them, and ultimately you will be getting that BC upon QR, that is equal to K, and we have already seen that this K is actually equal to AC upon PR, that's equal to AB upon PQ. So we can say that, I'm writing it over here now, that AC upon PR, this will be equal to AB upon PQ, and that will be equal to BC upon QR. Fine. This implies that triangle ABC is similar to triangle PQR. Right? If you have studied the concept of similarity of triangles, you might be getting it. So in that case, if these two triangles are similar, this clearly implies that angle B will be equal to angle K. And once you are done, you can simply write it QED, that is, you have done it with complete demonstration, with quad at demonstration. Right? This is what you are supposed to do. Fine. I hope the concept is clear to you now. The next example, let's move on to the next example. Now this says that we can consider a triangle ACB, that is the right angled at C. That means ACB, alright, that is right angled at C. Alright. And here we have this AB equal to 29 and BC equal to 21. Right? Now this time, let's say I have to find out the values of sine A, cos A and tan. I have already informed all of you that whenever we have a trigonometric ratio, whenever we have to calculate a trigonometric ratio, it will be easy for you if you can consider the angle between base and the hypotenuse, that is this one. But here we have to find out A. So again, need not to worry about it. What you have to do is just rotate this figure. And once you rotate this figure, go ahead, select it and rotate it. Fine. Now let's say, okay, yeah. Now you can see that this angle A comes over here. Now the hypotenuse remains same, but the base BC has been turned into the perpendicular. So let me write these numbers again so that it will be easy or convenient for you to understand it. This, alright. Now this point is A, this is C, and now this has become C. Right. And this time BC was a base previously, but now this BC is serving as a perpendicular and AB is a hypotenuse. Now you can easily find out all trigonometric ratios, right? What you can do is, like, first of all, find out the value of AC. So as per the Pythagoras theorem, this AC should be equal to under root of AB square minus BC square. Alright. Now in that case, this AC, this will be equal to under root 29 square minus 21 square. Again, some of you might be finding out the square of 29 and square of 21 and then subtract it. It's not required actually. What you can do is, like, you can use formula A plus B, A minus B, right? As you know that this formula, we have A square minus B square, that will be equal to A plus B, A minus B. Right? Now we can use the same concept over here. 29 plus 21 into 29 minus 21. Right? Then what could be the answer? 29 plus 21 is 50 and 29 minus 21 is 8. That will be equal to under root 400, and square root of 400 is 20. So we can find out that this AC is 20. Now if we have to find out sine A, that's why I've instructed you to rotate the figure so that you can get the correct values now, right? It is perpendicular upon hypotenuse, that is 21 upon 29. Initially, if you remember the old figure, it is BC was the base, but now since you have to find out the value of angle A, We have to rotate it, and now BC is serving as a perpendicular. Similarly, this cos A, that is base upon hypotenuse, right? Similarly, you can find the values for the tan A, cosec and cot A as well, right? Now, moving on to the next example. Let's say I have a triangle ABC that is actually right angled at B. Fine. And it is given to me that this tan A equals to 1. Again, we've got a problem for tan A, that is the angle made by the hypotenuse and perpendicular, right? And we are supposed to consider the angles which are made by the base and hypotenuse only. So, of course, we have to rotate the figure once again. Alright. Now, what we have to prove, that we have to verify that 2 times sine A into cos A equal to 1. This is what we have to verify. Okay, so I can simply write it over here like what is given to me, this tan A equals to 1, and to prove we have to sine A cos A equal to 1. Now, not to worry about, just rotate this figure so that this angle A should come down, and it will be considered as an angle made by the base and this one, your perpendicular, this hypotenuse. Okay, so now let me go ahead and make this figure. Alright, we have this figure, and now we can simply rotate it. Huh? Now, as you can see here, that this A is down now, right? Now this AB is a base. Okay, so now we can consider, let me rename it accordingly. This angle will remain right angled at B. This point will be A, and this point will be C. Alright. Now it is given to me that tan A is 1. So if we proof it, tan A equals to 1. Right. This implies that BC upon AB, tan A is perpendicular upon base, tan A, this is perpendicular upon base. Alright. So we can say that this BC will be equal to AB. Right. Now how we can find out AC? This AC can be found out under root A square root AB square plus BC square. Right. Now AB equals to BC only. So what we can do is like, it will be AB square plus AB square. That will be 2AB square. Finally, this will be AB root 2. Alright. Now, uh, yeah, what will be the value of sine A? Sine A is BC upon AC. BC upon AC. Now, this is BC upon AB root 2. Right? As you have already seen that this BC is equal to AB, so we can write it like BC upon BC root 2, or this BC numerator and denominator can be cancelled out. So sine A will be equal to 1 upon root 2. Alright, this is first equation. Now in the same goal, cos A, this will be equal to base upon hypotenuse, that is AB upon AC. This will be AB upon AB root 2, and that's equal to 1 upon root 2. Cos A equal to 1 upon root 2. Fine. Now, if you multiply the sine A by cos A, sine A into cos A, this will be 1 upon root 2 into 1 upon root 2. If you multiply it by 2, that will be 2. That is 2 upon 2, that will be equal to 1, and this is what you have to do. Right? I hope the concept is clear now. Now, the next point, let's talk about another example. Now, in this case, let's say I have a right angle triangle, something like this, and this is that right angle at E, then O, right? And it is given to me that in this case, this OP, this is equal to 7 centimeter. So we can write it as 7, right? And OQ minus PQ, OQ minus PQ, this will be equal to 1 centimeter. ठीक है? अभी क्या होता है, like we have to find out the value of sine q and cos q. Sine q and Again, we have a same kind of question that we have to rotate it. Alright, let's go ahead. Now, in this triangle OPQ, right, what do we have? We have OQ square. This will be equal to OP square plus PQ square using Pythagoras theorem. Alright. Now, from this given statement, this OQ is 1 plus PQ. So we can write it as 1 plus PQ whole square, that equals to OP square plus PQ. Alright. Now 1 plus 2PQ plus plus PQ square. Right? It can be written like this. Okay. Now we can take PQ to the right hand side. So what will happen? 1 plus 2 times of PQ, that will be equal to OP square. Alright. Now what is OP? This is 7. So we can say that 1 plus 2PQ, this is 49. Or in other words, 2PQ, this will be equal to 48. So PQ will be equal to 24. Right? Now we have PQ equal to 24. Alright. So now we have to find out OQ. You can find out OQ using Pythagoras theorem also. But it is given to you that this OQ minus PQ equal to 1. So in that case, this OQ is 1 plus 24, that is 25. Fine. Now we have values PQ equal to 24, OQ equal to 25, and OP equal to 7. But don't forget that we have to find out the value of sine Q and cos Q. Alright, because most of the students will do it wrongly, and they will in a matter of overconfidence, they will find out the value of sine O, which is not required. You are supposed to find out the value of sine Q as per this question. So what you have to do is again the same thing, same concept that what you are doing for the first question. Let's say you have this triangle, you have to rotate it so that you'll get the angle which is there for the base. So here now it will be Q, this will be P, right angle will be there, and this will be O. Right? OQ, that is hypotenuse, is 25, PQ is 24, and OP is 7. I hope now you can find out this value of sine q and cos q. Is that clear so far? No problem. Let me know if you have any question or queries like that. Okay. All right. Now, one more question. Let's say we have a triangle that is right angled at B. All right. This triangle is right angled at B. So here we can find we have A, B, and C. Fine. And it is given to me that this tan A, this is equal to 1 upon root 3. Fine. And we have to find out the value of, let's say, sine A cos C plus cos A sine C. Okay. Now the thing is like, see, let's say the thing is tan A. If you try to figure out the values of sides first of all, this is actually AB upon BC. Fine. AB upon BC, and that's equal to 1 upon root 3. Fine. You can multiply its numerator and denominator by k. So the length of AB will be equal to k. Length of BC will be equal to root 3k. Okay? This will be root 3k. Now we can rotate this angle as well whenever is required. That's this later on also we can check it out for the side also. This AB is this k, BC is root 3k. Alright. And what should be the value of AC? This is equal to under root k square plus 3k square under root 4k square, and that's equal to 2k. Right? Fine. Now let's say you have to find the values of C first of all. What are required? You need cos C and sin C. Alright. Now sin C perpendicular upon hypotenuse. That is k upon 2k, that is 1 upon 2. And sin C, sorry, cos C base upon hypotenuse, that is root 3k upon 2k, and that's equal to root 3 by 2. Alright. Now what we have to do is like again the same way what we have done so far. Have a triangle, right? And rotate it. So now by this way what will happen? This A will come down, B will remain here at 90 degree, and now this will be C. Okay. Now this AB, that is base is K, BC is root 3K, and AC is 2K. Now sine A, this will be root 3 by 2, and cos A, this will be 1 by 2. Fine. Now if you multiply sine A by cos C, sine A by cos C, that will be root 3 by 2 into root 3 by 2 plus cos A sine C, that is 1 by 2 into 1 by 2. Alright, that is 3 by 4 plus 1 by 4, that will give you 4 by 4, that is 1. Right? So this is how you can solve these questions. So I hope so far the concept is clear. Please let me know in case if you have any further doubts. Have a nice time and take care of yourself. Bye bye.